I mean, I'm writing on this. It doesn't pick up my hand. Alright. So. No, it came with the board. I got this board last year. So. Okay, so interquartile range. We touched on it yesterday. I just gave you the formula, gave you a Cole's note version. But the feedback I get is we don't know who Cole is. And we didn't understand his notes. Am I correct? Alright, so which is fine. So, we're going to go through how to do quartile. It's super easy. Okay? Guaranteed 95% pick up on this. Okay? So first of all, you have a piece of paper out to kind of jot down with this. Yes, I gave you a note. I gave a couple people a note in class already. So I knew they'd be appreciative. Right? So first of all, what's the range of our data here? The first thing we have to do, and we are doing interquartile range in a box and whisker plot, even though that sounds like a cat. Okay? So what's the range of our data here? And how do we do range again? Right? The high minus the low. So what's our lowest data here? 2? Oh, 1. And what's our highest? 17? So that's our range. Now what's our median? What do we have to do for our median? Put them in order, find out what's in the middle. I'm going to type them in so it's neater than if I were to. How many data points do you have?
It's 11. So it's 10. It's 9 and 10.
Do I have 15 on there?
Yep.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So we have 15 points on there. And our median is the middle point. So what's half of 15? What's going to be our middle point in 15? Or the 8th one, right? Right, so we go 1, 2, 3, 4, 5, 6, 7. So realistically, there's our middle, correct? We have 7 this way and 7 that way. 1, 2, 3, 4, 5, 6, 7. Do you all agree on the median?
Yep.
There? Okay. Yeah. Yeah. Okay. So the element, if we look here, the median is also the second quartile. Okay? Or for lack of a better term, if you use a notation, Q2. Right? If you want to put it like in a football analogy for people who like football, it would be like the end of the second quarter, right? Halftime, right? Now Q1 would be the end of the first quarter. The median of the whole data is the second quartile. Yeah. Then Q1, the first quartile, I'll do this in a different color. Let's go blue. Q1 is actually the median of the first half of the data. So if we kind of just zoomed in, for lack of a better term, on this, I can't get rid of that part, but we just zoomed in on this, right? And took the median of that. So how many total are there? There's 1, 2, 3, 4, 5, 6, 7. So we're going to be, the middle number will be right here. There's 3 in front, 3 ahead, right? Now, could you make a logical guess of what Q3 would be? And also the median of what? If Q1 was the median of the first half, Q3 is going to be the median of the second half. And Miles, you're right, it is 14. There's a boy named Miles online, so if you see me talking randomly, I do believe they would like to know that they exist. And sorry for calling you they. People online. Okay? So, now hypothetically, if we were to go back to like the equation I gave you yesterday, right? What was the equation I gave you yesterday? It was like a quarter times n plus 1, right? It was plus, I'm pretty sure. Now, how many do we have here again? 15?
Yeah.
Correct? 15 plus 1 is a quarter of 16, and a quarter of 16 would be term number 4. Now look at term number 4 is our first quartile. That was our equation to get the first quartile. So do you see how the equation links to logic and just figure it out? So if you want to use the equation to find the quartile numbers, that's perfectly fine. If you just want to string them out, find the median of the whole, find the median of the first half, find the median of the second half, that's fine as well. The old saying is that 6 of one, half dozen of the other. For the people online, if I ever go too quick or you don't understand something, just tell me. And actually, I brought. Shoot. I thought I brought headphones today, so they could talk to me. I'll find them in a little bit. All right. Now, if you know you're going to ask for a note later on today, you don't have to write everything down because that's on this note. Okay? But if you like making your own notes, I'm perfectly fine with that. Now, we're going to work on something. Now, because 25% of the data is here, right? And 25% of the data is here, hypothetically. That means 50% of the data is between Q1 and Q3. Does that make sense to everyone? Because these are essentially split up in the quarters. So that 50% is called IQR, which is, oh no, I gotta type this out here. You guys are gonna kill me. Can you guys see that color or not? Yeah? Well, this is funny because there'll be someone in this room, most likely a guy who might be colorblind, who's like not understanding how to keep changing colors. Because they won't be able to see the difference between some of the colors. That's an R. Interquartile range. Oh, why doesn't it want to write there? Oh. Okay. So that is Q3 minus Q1. Okay? So in this case, 14 minus 3, which is 11. Okay? And that will come into effect when we do a question next. That doesn't make sense now, like why do we pull this number 11 out? But once we make our old whiskers graph there, it'll make sense. I really like your sweater, by the way. Okay. What sport is this? The football? Yes.
I know that was a question on the system that was look through the numbers, but what's the 11%?
That's the interquartile range. It'll make sense once we do the whisker graph. It'll make sense. Okay.
What's the title of the video?
It's supposed to be quartiles. Oh, I'm currently having some stomach issues. Okay. Not a problem. I'm recording the lesson. No, I'm not telling you who it is. Although this really reminds me of my favorite part of Dodgeball. Dodgeball, the movie, where the big guy comes out of the washroom and says, "Excuse Michelle, he's having some stomach issues." Oh, it's good.
Is that your favorite movie?
It's up there. It's like top 3.
It is a really good movie.
Although my wife likes it too, so like we can pull it like that line and we,
Yeah. It's a nice one to take a look.
oh yeah. Okay, so in the next little bit, how come I put that in there already? Actually, write down that.
They all in frame?
You guys see that? Yes? To save you from putting them in order, because I trust you can, write those down, and then we'll go through the interquartile range and everything again with this. I would still write it down to give you the practice. Pardon?
Like these are checked for the first, like the 14.
No, this is a new question. This is a new example.
So you don't have to write them down in order?
Write them down here.
Oh, they already are?
Yeah, I want you to write them down in order so then you can do the calculation.
You just put these down.
Yeah. I'm not gonna. I'd much rather spend my time doing other things than waiting for you guys to write down numbers in order. If we have to teach you how to write down numbers in order, we have bigger issues in learning this part. Now, do you guys have a way to chat separately on Teams with people?
Yep. Yeah.
That's what I thought. Because I can always see people typing. Like when I'm teaching, I can see people typing, but it doesn't come to me. Because I can see like so-and-so is typing, but then it never, like at first,
You just stop typing them.
yeah, but there's people who I never hear about, like when I was teaching the 3M, there's people who never wrote in chat, but always see typing.
Oh, you just stop further. That's concerning.
I can't see what you're writing, but I just see so-and-so is typing. I'm not throwing Diego under the bus right now because I see you typing. No, that's not Diego. Oh, I don't want the answer yet, Diego. We're just writing down the numbers. For the record, Diego's arguing the answer to this question.
Probably smarter than I
Alright. Alright, let's pause that. We'll do our course option presentation. I know. I don't know why we have to do it at 9:30. That's a different question. But we're all supposed to do it at 9:30. So, okay, ours is like 3 minutes long. For the people, Marley, you pay attention, and Miles, Miles, you pay attention. Everyone else, 3-minute little break.
Very quickly, about 12 plus. So we certainly welcome any grade 12 students back to St. James. But I always say grade 12 students, if you're coming back, you want to come back with a plan. So, is there courses you need to upgrade, courses you need to take, get your program at college, university, you're going to co-op to help get you some more experience for that training or apprenticeship you want to pursue. Those are all good plans. Coming back for 12 months just because you don't know what you want to do and take some course maybe without interested in, that's not really a good plan. If you're back here for apprenticeship, you will do well. So that's what I would say to you is make sure you come back for 12 months. You come back with a plan, of course, in mind you want to take. Now, I have a entire PowerPoint presentation and video for grade 11 students that talks about all the courses in grade 12. Now, I'll certainly make that available to you to look at if you want to, but I don't want to take up much of your time here. But you do need to know, just like any year, your courses are due in my blueprint by Friday, February 26th. So I'll just remind you how that happens. Here's my blueprint homepage. You are very familiar with this by now. You already know what the username or password, or if you're on a school device, you can simply click on a school login, then you're logged in Catholic. You log this way. Finally, you can also log in on the Login Catholic homepage. You want to look soon. Once you're in, you will go to high school, and what you will see with all your courses for grade 9, grade 10, grade 11, and grade 12 with marks. The 12 plus, you simply click on the plus, and there you go. You add your courses. It's that simple. You review your course sections up here, and then you submit it. I want to remind you that you want to be doing some research. If you're going to college, university, doing training or apprenticeship, your Ontario College website is a good one. You simply click on programs and search by keyword. This is good for a college program or training or apprenticeship. And for university, the Ontario University Student Pro website is best. Click on programs, same thing. You search by keyword. And don't forget that in my blueprint, there are also actions to search for post-secondary opportunities here or application. And that's really all I need to know. Again, if you want a detailed PowerPoint or video to watch, I will send it to my email all grade 12s. But I would guess you probably know most of these things by now. So what you need to know for sure is that by Friday, the courses are due. If you have any questions, of course, you're here guys to help you out. You can email your guidance counselor directly. This is Mary, takes care of last names AF. I take care of last names GP. Mr. Paul takes care of last names Q. Yeah. I think that's about it. So thank you for listening. Any questions? Feel free to ask us. If we don't see you, talk to you soon. So take care of yourself.
It was made with the assumption you guys were going to be, didn't know if you were going to be here or not, hence the weird back and forth there. Okay, where am I going here? Who filled that out twice? Okay. So, has everyone got their numbers down, or you need a couple seconds? Couple more seconds? Okay. And I'm going to leave it to you right now to figure out your Q1, Q2, Q3 numbers. Okay? So, what's your Q, how do you find Q2 again? You can use the formula, or you can use the median. Correct? Q2 would just be the median, or you can use the formula to find it. Okay? If you're using the formula, you use half in front of the n plus 1, n representing the number of terms. Okay? And away you go. Diego, you're a little bit off with your numbers, if I'm not mistaken. You're just off a little bit. So take another shot out of there. How many total terms do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Did I only give you 23?
I got 23.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, Diego, that's why you're a little bit off. Here, I'm gonna say it. You guys tell me if it's there. 88, 93, 80, 68,
Yep.
44, 71, 72, 73, 66, 65, 63, 43, 75, 76, 78, 81, 75, 52, 47, 64, 75, 79, 85, 91. How do I list them all? But
Is there 375?
there's 375. There's only 2 there. Okay, add another 75. Okay.
Yeah, I was gonna say.
So add a 75 right in here. Yeah. And 24 terms. Or 24 numbers. Sorry about that. Would you like me to do it online, like up here with the formula or without the formula? So both?
Yeah.
Okay. So, first things first, we have 24 terms, correct? Halfway is going to be, what, 12 and a half? Correct. We added a second 70. We had 375. Okay? So halfway, it can't be 12 and 12, right? So the halfway one is like 12 and a half between those 2 terms. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? So there's 12 right here and 12 right here. So we're going to take this number right here. Does that make sense? So we have to go, now it is 74, right? Because what you do is you go 73 plus 74, sorry, 73 plus 75, sorry. Dante's got me all crazy here. Divided by 2, which equals 74. Q2.
Couldn't you just run on how I got that? Is the number between 73 and 75?
Correct. Yeah, I'm just showing you the mathematical reasoning for it. 100%.
So if the numbers are like further apart, you have to count them, right?
Yeah. Because you could have like 0.782 and 0.834. Right? And my brain doesn't work that quick. Right? So then, to find my Q1, I know I have, how many terms here? I got 12, correct? So I'm going to go 6.5 in. So 1, 2, 3, 4, 5, 6, right? So there's going to be 1, 2, 3, 4, 5, 6 on this side, 6 on that side. I'm going to take the middle of these 2. And if we use big brain math, such as, there we go. So the middle number there is 64.5. The same thing on this side. 1, 2, 3, 4, 5, 6. Right? And the middle there is going to be 79.5. feeling about quartiles is much better than yesterday? Now, can someone find me the IQR code? Not IQR code. IQR value for that? It has QR in it, which makes me think of the QR code. Not yet. Give everyone a second. Use the Q3 minus Q1. What color is that? Yes, it says 375. Yeah. Yeah, I missed it at a 75, so I added it in there right here.
Yeah, yes it is. Red velvet's not a flavor. It's chocolate.
No, it's not chocolate.
Yeah. Yes it is.
Okay, we'll talk this later. Okay.
Wait, can your recording pick up our voices? Like, if Dante talking about red velvet in a movie?
Okay. So the IQR is 15. Okay. Okay, what that means, I'll write down the statement down first, right? I'll type in the statement for the sake of you guys not having to deal with my writing. Okay. So what that means is that 50% of the ages have a range of 15 years. So in your data, 50% of your ages would be within 15 years. Does that make sense? And then we'll make a nice whisker graph here to start. Relax. It's the easiest graph I ever made. It's more of a, don't think of it's not a graph, but more of a, you're transferring IQR to a visualization, which makes it a little bit easier to identify and look at. Yep.
So how would you find out
How would you do with the formula? Okay. So, I'll do Q3. Okay? So if I want to do Q3, I'm looking for 3/4, correct? So it'd be 3/4 times, how many terms I had? 24 terms, right? 24 plus 1, because the formula is 3/4 n plus 1. So that'd be 3/4 of 25, which is, what's 3/4 of 25? 17.5? I'm holding it to you. 18.75. What? What happened there? 24 terms. $18.75? Yeah, so it'd be your 18.75 term. Does that make sense? Is that right? Let me see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it's going to be in between those two. It should be 18.5, I'm not sure. You understand what I got there? For some reason 18.7, I'll look into that. But that is that exact same term number, right? Because this gives you term number, not a value. It's that term number. Make sense, Mia? No. Yeah. Pardon? No, that's just for finding the quartile using the formula.
What was 24 there?
Because we have 24 terms. Yeah, how many terms you have plus 1? 18, that's 18.75 terms. That gives us, like, we count down the terms at 18. Yeah, which equals the same as that number. Okay, it just gives you the term number. Okay. Pardon? No, it's not. It's 18.6. It's 18 and a half terms. So that's why I counted down the line. 1, 2, 3, 4. And you get to that term number. No, it's just a different way of doing it. There's a formula way of doing it, and then there's like the median way of doing it. You pick whichever way you think you like best. Okay? Alright, here we're going to draw a whisker plot. Okay? So, the first thing we do for you guys, just draw a straight line with how many marks do I have on this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, maybe, something like that. So what we're going to do here is we're going to, first step, draw a number line that encompasses the highest number and the lowest number. Highest and lowest value. Yes, they'll be evenly spaced out. So what's our lowest value is what? 43. Our highest value is 91. 93. So realistically, I would start here. Now, what your numbers are, it doesn't matter. But 40, 45, 50, 55, 60, 65, 70, 75, 80. Maybe have to count out loud, stop judging me. Yeah. Now, hypothetically, if you went by tens, you go by tens. You need a number line that has the lowest number in it and the highest number in it. Okay? Now, don't go by 55s. Okay? I don't know if I can mark you wrong, but I would try. It wouldn't be as accurate as it could be. We're going to skip over step 2, which is title and label the graph. Yeah. You say like, what would you graph this? This would be whatever data we're using, like whisker graph. Right? Follow it. I'm going to zoom out here so I have all my numbers. So, we're all set? Then you're going to put a dot at your Q1 number, a dot at your Q2 number, and a dot at your Q3 number. Okay, I'll color code my dots here. So 64.5 is going to be about here. Is that black? Yeah. 74, right there. And then 79 is about here. Does everyone agree with me? Yep. So Q1, Q2, Q3. Then we're going to draw a box around the data. A box connecting the two furthest points. So in this case, I go like this. Does that make sense? So connecting the Q1 and the Q3 numbers, you draw a box. And also draw a line through your median. That's the worst line ever. So that's your box part. And then the whiskers refers to, I'll make this line a little thicker. You draw a line to the left to your lowest term, your lowest number, and draw a line to your right to your highest number. So if I was going right, we said our highest number was 93, right? So I draw a line like this. Then our lowest number was 43. So we draw a line like this. Yeah. Yeah, that's our Q2 number. So if you look at it like Q1, Q2, Q3.
Oh, it doesn't have in the middle of the actual.
No,
Okay.
no, because this gives you a visualization of, in this case, the median skews a little bit to the right. You binder? Yeah. There you go.
Yeah.
So this gives you like a little description of like, okay, 50% of the value, like that box represents 50% of the people, right? You can also see like the median kind of shifts a little bit right, so you can kind of assume like there's more taller people than actual. So it's a visualization of the data, more than a literal graph. Ça va? All right, time for the fun part. No, standard deviation. This is like the most important thing you'll do all year. Oh yeah, but this is like where everything's based off of it. Like to this day, now this will sound really geeky, but I've told you my wife's a scientist, right? So she deals with stats and like deals with this stuff like not every day, but a lot of the time. So we actually had a discussion yesterday about, okay, because there's actually 2 standard deviation formulas, and where I was like, why does this exist? So she literally brought out her stat book, which is a book this big that she has on her shelf, and like flipped through it from, I think she got it in university, and like flipped through it, she went through it. This is stuff like that you read about all the time if you go into like higher education and understanding like standard deviation. Would you like a note? You good? Alright, I might give it to you for the middle thing. Okay. I want everyone take it, you can get back to me at the end, but the second page is what we're doing, the standard deviation. Can I keep it on one? You keep it if you want. You guys are going to know online. You want that?
Yeah. There's like 8 of them. Yeah, like every single.
No. Who? No. No, I don't pay attention to Versa. Oh, I've seen that guy though.
Oh, he's the creator. Yeah, he created Versa.
Okay. So for people online, we're going to work through the second note. For my people who are new, if you go into OneNote, Adriana or Miles, you can click on OneNote. If you go to Content Library, under week 1, it has a filled out note. So a complete note with everything filled out. You scroll up. There's a note that I go through that I lead in class, and then there's also, I'll post the videos of class after here. So if you want to go through it like on a separate screen and look at the paper, you can go there. Okay? Alright, so the first part of this is not in your package. Okay? Because we're just going to kind of talk about the importance of standard deviation and things along those lines. Okay? So, you can have a piece of paper separate and just jot these numbers down and kind of practice along those lines. Okay? So we have two students, John and Jane. Okay? And here's their test results from, I don't care what course. Name me a course that this is from. That's boring. Math. Alright. So here's their math marks. Okay? How can we tell what information, who's the better student? How do we know this? Okay? So how about if you're on this, it's not on that part. Because you don't, this isn't necessary. The part that I put on your package is the stuff I really want you to know. This stuff is like getting to it. So if you're on this side of the class, you do John, you guys do Jane. Then do John. Oh my gosh. Oops, sorry. What am I looking for? I'm looking for this. Sorry. Wrong one.
Yeah, it doesn't matter if you're consistent with that. Those 62, I mean, you don't want to put that line in the lab. But even 45 is better than 18. So you know what he's saying.
You want us to round if we don't
Yeah,
get a
but
whole number?
Pardon?
You want us to round if we don't get a whole number?
Yeah, round in this case.
It doesn't matter if you're consistent. That would be like, if they're saying, well, both good consistent, you average 5 points a night. Would you rather have like,
So what is this? We don't know.
or would you rather have,
You just have no mode then.
I don't know.
Yeah.
It's like spud web, drama, 40
Okay,
once a year.
here we go.
They're gonna get 5 points.
So who can give me John's mean? Who has John's mean? That's this side, isn't it? Opposite of me. Yeah. 67.2, 67, right? You get 0.9?
I got 5.
0.5? Alright, that's fine.
Is that what you're talking about, and then divided by how many you have?
Correct. What's John's median? 68? Perfect. What's his mode? There is no mode, right? You didn't repeat a mark, so there is no mode. Okay? What about Jane? 66.2. Median? 67. And mode is 70 and 62. Right?
No, I'm putting down.
So they both have similar averages, right? That's the only thing we conclude there, right?
And similar median.
Well, median's an average. It's a different type of one, right?
So who's more different? One of these tests, other than John or
You never know. You know that Jane works night shifts,
I just looked at that.
and we have a rotating schedule, and those are morning exams, and those are afternoon exams, right? Yeah. So you don't know. So essentially inconclusive, correct? Mean, median, mode are good ways to find the center of data, but it's inconclusive, right? This information, such that blah blah blah, is important to find out how spread out the information is. Like, this tells you an average, but it doesn't tell you the spread, correct? Of what's happening, what really is happening. Okay? So for example 2, consider the 2 data points and calculate the mean and median of these 2. So we have a frequency, set A frequency, that looks like, what kind of distribution is this? Pardon? Normal. That looks like a normal set of distribution. Okay? Now, in the sake of time, I'll give you the answer for that. 8 and 8. Right? Because realistically, if we have a normal distribution, our mean and median are going to line up right there, correct? Now this distribution looks totally different, correct? Besides being the name of the one I never remember. Uniform, right? Because this person here had a wide range, 0 to, goes all the way up and all the way down, right? It's got some low scores, got some high scores. This one here, 3 4s, 3 6s, 3 8s, 3 10s, 3 12s, right? But also has a median and mean of 8. But very different data. Do you agree with me? Right? So then, something can be done to further look at, we can look at the range. The range of the data. Right? So if we look at the original range, we had a high score of 16, we had a low score of 0. So we had a range of 16. Correct? This one here, we had a range of 12 and 4, so the range would be 8 on that. Okay, so who's the most consistent person in that state? Like, person A or person B? Who's more consistent, do you think? This set of value or this set of value? Consistency, yeah, because the range is small. Okay, even though if you just looked at mean and median, you'd be hey. And if you look up here when we looked at these test scores, that's where we had an argument over here about consistency, right? Besides being much more variable. I'm not telling you you're right yet. Alright. So example 3. We have 2 twins, Toby and Moby, who both work at a pizza shop. Their manager, for some reason, has decided to give, well, they're going to give the raise to their best employee. Okay? So she looks at the data. Because they do track everything at Domino's. You don't work at Domino's, do you? No, okay. Someone with your same facial features.
Works at Domino's?
Who works at Domino's, I think. All right. So we have to figure out who's most deserving of a raise here. Okay? I will give you the mean. You guys figure out the range. Okay? I'll give. We're getting there. Okay. Pardon? No, it's. You're the next. That's the next page. Right? Because I don't think I need you to copy that down. Like, do you guys really need to copy all this down? No. Well, some people like. No. So what's our range? Who's got a range for Toby? 168. Who's got Moby? They're both 168. Right? But one person's going to be more deserving of the range than the other. I mean, of the raise than the other. Okay? So, still, it's inconclusive. Right? So we need to figure out a way to realize what our data is telling us than just mean and range and median and mode. Because it doesn't give us like a true sense. Like how can we, like where's our guy here, Moby? What the hell happened on the 12 day, right?
Moby had one too.
Oh, you had one too? Okay. But if you look at Moby, he seems to be like always, he's more consistently in the hundreds.
When he started, he had 132.
Right? Compared to Toby. So we need something to tell us what the data is saying. So this is where standard deviation comes in. Okay? And this is where, if you look in your note, you can fill in this part of your note. It's all I'll write in here and then I'll fill in a little top here. So standard deviation is the best choice for measuring the consistency. Consistency of data. Okay? I'll write in here also the little side note. Okay. So it gives you the average difference between the data value and its mean. Okay? You can on the side if you want. Okay? So it's essentially telling you how far you're off your average. Correct? Adam was talking about basketball terms. Right? About a player who scores, let's say his average scoring average is 20 points per game. But he consistently scores like every game's either like 18 or 22. That person's very consistent. He's going to score 18, 20, or 22 every game. He's just within there. You could also have someone who averages 20 points a game, who scores 40, then 0, then 10, then 30, then 0, then 40, then 0, then 0, then 80. Right? Those two people are very different, even though our averages are the same. Okay? So, here is the formula for standard deviation. Okay? I would suggest writing this down on that blank sheet I gave you earlier. And for the people online, if you go to your reference page, under your name, there's a blank sheet. That's like a summary sheet of all the things that we've done today and tomorrow. This one? That means standard deviation. That little symbol means standard deviation. The X with the line over it is the mean. Okay? That means mean. So I'd also add in that symbol to where we have the definition of mean and how to find mean on your page. So it's not that bad. This here, oh boy, I just lost it. Right. I'm getting there. I forgot to press my. Okay, this here. Now it seems scary. Don't be scared. It wants to be your friend. That there is the symbol for standard deviation. Okay, that's what we're working on right now. This symbol here, oh, that's a big fat line, isn't it? Didn't realize it was that big. That's the symbol for your mean. Okay, I'd also add that to X with the line over top of it means mean. You can always eat. You can always eat. I don't care if you eat while I teach. Okay, as long as you're facing forward and not like showing off how much food you have. Okay. Okay. This here, so is everyone caught up to where I am right now? I'll wait till everyone's gonna. This symbol here is called a sigma symbol. All it means is sum it up, like adding all the numbers up. Okay? This part here. And what the bottom number and the top number mean is like where you start and where you end. So it's telling us here, we're going to start at integer number 1, so like point number 1, and n means we're going to go to the very last point. Okay? And n is just a number. Don't worry. Oh yeah. Pardon? This just means add it up. It means, don't worry about it. It just means we're going to add up. This all it means we're going to add up all the points. So this is like point 1, point 2, and minus off the mean. We're going to work through this. Relax. Okay? Well, hypothetically, my wife would never do this on a calculator. You plug all the numbers into Excel, and Excel will do it for you. But I will not give you a full list of numbers of like 100 numbers to work through. Let's be quite aware here, right? So you might get a numbers like 10 numbers. But it's very important. Like, you guys are like, why do we need to do this right now? And the answer actually came in the conversation my wife and I had yesterday about, what were we talking about? We were talking about variance. And we're actually talking about the different formulas. Because there's actually a formula that looks like, there's a standard deviation formula that has that on the end of it as well. Okay?
So your wife uses this for her job?
Yeah.
Besides that job, what do you use for?
Oh, if you want to understand any stats, if you want to go to, like when you go to college and you read a paper and you look at distribution, if you're looking at data about like COVID right now, this would be all over, like standard deviation. Like like today, like this morning part, we're just learning how to calculate. Then this afternoon, like later and so on, we're going to learn how to interpret the data, which is the more important part. But you need to understand how you get the data first. Oh yeah. This is easy. It's not bad. I'm trying to make you relax a little bit. Alright. So here's what we're gonna do. We're gonna split the group up again into Toby and Moby. Okay? Toby's group is gonna get a little bit of a benefit. So I take a look at what was Toby's. Toby's average was 104, correct? From up here? Okay. So what we're going to do here with all these numbers, this x minus, so what it's telling us to do is we are going to add up all the difference between a data point and his average. Okay? And we're going to square. That top is just going to say we're going to add up, we're going to take a data point minus the average, like one of these numbers. Like 54. Pardon?
Like if you look at the chart, aren't those all the data points?
Yep.
Is that the data points that you're
Correct. Correct. We put them here so you could work it through. Right? So we're working through here. So then for this one, I would go 54 minus 104 equals 50. Okay? Then on this side, I'll wait till everyone finishes writing or texting their parents, help me. I learned what standard deviation is. Okay? Then on this side, here, we're just taking the answer we get here and we're going to square it. Okay? Sorry, negative 50. Right? So in the equation here, it's asking what's the difference between like whatever data point it is minus the average. We do it here. And then we're going to square. So that would be negative 50 squared, which equals 2500. I feel like I should get a shield here later in the semester for when I really get You mad, you might throw something at me. Okay, for the next one, 152 minus 104 equals 48. 48 squared equals 2304. Ça va? Do we see where? See? So, how about this side of the room? Who'd you guys do last time, Toby or Moby? Okay. How about you guys have Toby, you guys do Moby. So Toby, sorry, Moby's on the next page. If you flip it over, Moby's on the next page. Yep. $54 minus 104. Right? But when you square it, it's just going to become positive anyways. So, they had the same mean. Okay? Thumbs up, thumbs down, no driving fingers.
You know the one that you drive with when you're angry?
It's the one that you use when you drive when you're angry.
Oh, the one I flew.
Diego, once we're done this little lesson, you guys will have a chance to have break and do some homework questions. Yeah.
We're talking about the finger when you're driving?
Yes, that's your driving finger. It's about the size. That's about the size of your carotid artery too. The artery that goes through your neck.
Yes.
Yeah. My prof at university taught me that. They were free. Yeah.
Wait, like.
Where'd you look at?
Yeah. So the.
Where's it measured from though?
No, like the width.
Oh.
Like if you took this, like this is, like if you, right?
I know you can find your phone.
You know, but those ones there are that big. Going up there, that's how big they are. Okay, let's keep her going.
Remember when we were bowling one time? I have math. Where you are?
Where you at?
You show my math. What is oh my gosh. That Michael Jackson runs. You watch Cars?
There's a little right ring.
You don't see it. Very left. What happened? What? You don't see it all the time. Yeah.
Okay, now once you get your total, you're going to add up all these numbers, like the 2500, the 2304. You add up that. Then you can finish off the equation by taking your total, dividing it by the number of data points, which is 8, and then take the square root of that number.
Wait, what did you say?
So once you get your final number here, you're going to add up all these numbers right here to get a total. Once you have that total, you take your total, divide it by the number of data points, which is 8, press equals, and then take the square root of that number.
So that's like the whole formula there.
Correct. Yeah. The formula looks much more daunting than it is.
So if you do this, this is like doing that big equation.
Yeah, you just did the whole equation.
Wait, doing all these points, we just did the whole equation?
Yeah. Well, we're doing that plus the dividing. Like once you have your total, divide it by how many data points you have,
And then we're done?
then take the square root of that number.
This was so much easier than my dad teaching last time.
Oh.
I had her for 3 days. Who did you grab?
44.25.
Or the thumbs up,
What is the square button?
Square root? Or square? X to the 2 problem. Divide by the number of data points we have, which is 8. We have 8 data points. Add those numbers, correct. Add those up. Yep.
Where did you get the,
We're going to do some work of a reformat. We only have
The answers.
No, can't do that. I never squared. No. You're doing, yeah. What you're actually doing was negative 2 times 2. Yeah. You divide by the number of elements for then a square. Okay, yeah, I see that. Yeah, I see that. Yeah. You might have a calculator that's standard deviation like oh.
I'm not thinking yet.
Now, some of you are punching in your calculator.
2,667.
Some of you are punching your calculator negative 2 squared. What that is it's negative 2 times 2. So you'll get negative 4. But some people, depends on the calculator. But realistically, if you know a squared number is going to be a positive, don't put the negative in, just put 2. You know it's going to come in positive, right?
Mr. O'Byers, why doesn't my square root
Square
button?
would never be negative.
Yeah.
So you just put the negative and then change it.
Well then, did you try smacking it?
No.
Not all of
Hey,
them.
did you get 51.61?
Why is your, where's your pencil? And a reset.
Right here, but I already tried to.
Reset?
Yeah, I don't know if I actually
You have a D there for some reason.
Yeah, I don't know.
That's the worst then? Do this. 2, 6, 1, 6. Okay, I'll wait till after. That's a good start. It's your settings off.
I don't know. Mr. O, how many decimals do you want?
1.
What? Too late, I already did 3.
Oops. Oh my gosh.
What 2?
Yeah.
My paper? Oh,
One second.
I just did 2.
I definitely get the correct answer.
One second. How am I ever going to do this simple?
What?
Oh my gosh.
Wait, that's actually not bad.
How do you get 21?
No.
Oh, that's for the other, that's for Toby. I think.
This is
Okay.
Toby.
Yeah.
Yep.
What is the summer do? I got 44.
One second.
We're gonna
Let's
learn
try.
that.
They wouldn't do.
We can't hear. Oh,
What?
sorry, I turned my mic off. This one here is 44.2. Okay? So we have, this is Moby's standard deviation, and this is Toby's standard deviation. What was the other standard deviation? 56.2? Correct?
No, 51.64.
51.6? Good. And my 6s always look like these. I have no clue. I think it's something wrong with the program. Alright, so who's the more consistent? Looking at standard deviation. Moby. Moby's got the lower standard deviation. Yeah, lower. That means like standardly he's like 44 on either side most of the time. Okay? So we're either 44 this way or 44 that way instead of 52 and 52, which is much wider. Okay? Let me write this down and I'll answer your question. because there's a little. So his. Oh, what was I even writing? Maybe he's French. Bye. There we go. Oh, I've learned. Right? So Moby should get raised because he has a lower standard deviation. So he is more consistent. Oops. Okay? Therefore, lower the standard deviation. The more consistent. Right? So it's really good when you're looking at like research. Like let's say I was taking a look at no, let's say I was taking a look at like Mark's let's say we took a look at like university marks in first year stats, right? And we took a look at the people who come from this class and the people from the class next to us, correct? Right? A consistency, like a standard deviation would be like, okay, if you come out of this class, if I had a lower standard deviation, it's like you're going to be consistently in this range, right? Where if another teacher had a wider, you'd be like, okay, if I come out of that class, who knows? I could do really well or I could come out doing really poorly. Does that make sense? So it's really important when you look at, like, data is not the same. So who's got the stronger set of data? In this case, Moby does, because he has a lower standard deviation. Okay? That was a long lesson this morning. Okay? Do we have okay sense on it though? Right? Sometimes they take too long to teach comparative, but I think it's to. Oh, sorry, I never answered your question. Go ahead. That's the end of. If you need to, that's fine. Right? You can. I think there's space there for you kind of like explain what to do, but don't write it yet.
So for this is this formula.
Correct. So that adding there, like what you did in here. Yeah, go ahead.
Hmm?
Yeah.
If it's on the test, you can give us a chart.
I'll take a look. But you're gonna do it like a whole bunch of times, like right now. Like realistically, you can make like you know what this chart looks like now. You can make it yourself, right? Like this here is all this here. What you did there, if that makes sense, right? So what you did there to get that number is that top number there. Does that make sense? Yeah. Then you're just dividing by n, which is number of data points. Okay. The number of points you have, right? The number of like information slots. So like this morning's homework, and I guarantee you won't get through all this morning's homework. Let's go to Adam, week 1. Tuesday homework. Ooh, we can put the numbers up for you today. I'm getting better. Right? So there you go. Calculate the standard deviation for the following things. So there's like 3 times there that we calculate standard deviation. So doing exactly what we just did.
So you would find the median for that, right?
Find the mean first.
Yeah.
Find the mean first.
And that's the number, like that's the 104 for this.
Correct. Right? You find the mean first, then you take them all, subtract the mean off it, square it, add them all up, divide by how many data points. Then here, we'll take a look at this real quick. Remember what it says, like, lower the standard deviation, the more, think about it, the more packed in your data is going to be, right? So which one of these graphs, let's start with the widest. Which one of these graphs would probably have the widest standard deviation? The most variance of the data? 1, 2, 3, or 4? I would say 3, because like a lot of people over here, a lot of people over here.
Yeah, but if you're like the numbers on the bottom of the graph, isn't it more spread out than if like?
Oh, I guess so. Yeah, it would be here.
Like a wider
I guess it'd be here because of the bigger number. Yeah. I was thinking just pure numbers.
Oh.
Yeah, it'd be here. Okay. I would say it's I, if I'm not mistaken. No, I. What was it? I. No, it's going to be a wider variance because the data is further apart. Yeah. Okay. Alright. Do you guys need a walk before we start? Or you guys...
Yeah.
I don't want it. Yeah, not really.
You want one piece of
I mean, my grade 12.
Well, you guys, if you want to go for a walk outside, go for a walk. What do you say we start up class again at 11? Okay?
11.
So you have approximately half hour to do this homework. What's that? I got to answer questions here. I'm not seeing the homework on OneNote.
I see it.
Let me go to your folder.
I actually kind of don't. See, that's why I think something's wrong. I get it.
File, week 1, Tuesday homework. Oh, content not available. Oh, thank you.